Every time we talk to you about feeder cables, bending cables, jumper cables, we always mention the manufacturer's bend radius. So why is it so important? When you bend a cable, you change the geometry of the cable, and this causes an increased loss. It causes power to be reflected back to a radio transmitter. It causes traffic, in the worst cases, to migrate from a radio base station and go elsewhere. The operator loses money. As an installer, you should not bend cables too tightly. We've got a test set up here, and I'm going to test a little piece of feeder cable. To my left, I've got a roll of 10 meters of wire. To my right, I've got another cable 10 meters long, and we've got a test instrument here which is measuring the distance to fault. This, by the way, is a typical instrument that would use to test a complete antenna system after we've installed it. The fault occurs as a spike. The bigger the spike, the higher is the fault. As you see here, we've got a huge spike, and this is because I've magnified the fault a lot. So we're looking in really microscopically at these faults now. And this actually is a normal reflection from a connector at the instrument. After my roll of 10 meters of cable, we have got a connector. And this is the connection to this piece of feeder cable. At the other end of the feeder cable, we have got another connector, and that's this one here. Then I've got another roll of 10 meters of wire, and here we have the dummy load at the end. And that's just a resistive dummy load pretending to be an antenna. Everything's okay so far. These are normal and acceptable faults. They are within limits. But let's bend the cable and see what happens to the fault situation. Incidentally, the bend radius of this cable is supposed to be 25 centimeters. If it's bent any sharper than 25 centimeters, then the manufacturers don't guarantee what will happen to it. We're about 25 centimeters now. And you can see a fault is starting to occur in the center. Now the fault is rising, and it's now going up towards unacceptable limits. At this stage now, traffic that are a long way away from the base station will begin to migrate elsewhere because the range of the base station will be reduced. And as you continue bending, you get a total and catastrophic failure. At this stage now, most of your traffic would have migrated, and that is why you need to adhere to the manufacturer's bend radius. Well, as you can see, we've exceeded the bend radius specification, but this cable is permanently ruined. We could try and straighten it up a little bit, but the cable is still damaged. So what have we actually done inside it? Well, the cable should look like this. The impedance of the cable is governed by the diameter of the outer conductor to the diameter of the inner conductor. Now then, when we bent it too much, as you can see, we squashed it. It's not even circular anymore, so this is permanent damage. So this is why we can only bend a cable a limited number of times, and even then we must follow the manufacturer's bend radius specifications.